Let's start off our operations with a power of a number in scientific notation. Let's start with this one. I'm going to do 5 times 10 to the negative 7th squared. Now this one is a product, 5 times 10 to the negative 7, all squared. So this is a power of a product. So I can take that power 2 and I can apply it to both of my factors here on the inside. So this becomes 5 squared times 10 to the negative 7 times 2. So simplifying what we've got, I've got a 25 times 10 to the negative 7 times 2 is negative 14. Now I've got an answer, but I'm not actually in scientific notation. Remember, to be in scientific notation, that coefficient out in front needs to be a single digit in front of the decimal place, a number between 1 and 10, but not 10. So I've got 25, it is too big. I've got here's my decimal place. I've got 2 numbers in front of that decimal place. I really want my decimal place to be here instead. Now there's a couple of different ways that you can think about this. I'm going to do this one like super technically first, and to get 25 to be instead 2.5, I would divide by a 10. And if I've divided the number by a 10 to keep this equal to the same answer, I can't just divide it by 10, but I can go over here and I can multiply by a 10. So we end up with 2.5. I want to show you a shorter way to think about it, times 10 to the negative 14 plus 1, I get 2.5 times 10 to the negative 13th. Here's another way to think of it though. Remember, we started with a 25. I needed to make 25 smaller by 1 decimal place, and we did that. And if I made it smaller by 1 decimal place, that means I needed to make the power on the 10 bigger by 1 decimal place. So if I am making the first number smaller, I'm making the power on my 10 bigger. Okay, keep that in mind as we're going through our other examples. Okay, next up, multiplication. In order to multiply 2 numbers in scientific notation, notice everything here is being multiplied, which means that I can use my commutative property. I can just reorder stuff. So I am going to reorder this so that I've got my coefficients multiplied together. So that would be a 2 times a 3. And then I'll write my multiplication symbol here. And then I want the powers of 10 multiplied together. So that would be my 10 to the 5th times my 10 to the 4th. 2 times 3 is equal to 6. Times 10 to the 5 plus 4, and we end up with 6 times 10 to the 9th. This one's already in scientific notation, no need for an adjustment. Here is the next one. I'm also going to regroup this. So I'm going to go ahead and take my 3.2 times 4, multiply those coefficients together, times, and then my powers of 10 get multiplied together. So I've got a 10 to the 4th, and I've got a 10 to the negative 17th. Let's go ahead and do that 3.2 times 4. So just off to the side here, 4 times 2 is 8. 4 times 3 is 12, and I've got 1 decimal place in the original problem. So I've got 1 decimal place there in my answer. So that gives me a coefficient of 12.8, the product of those first 2 numbers, times 10 to the, I'm going to put this right here actually, 10 to the 4 plus negative 17. 4 plus negative 17 is negative 13. Almost there, right? I just need to fix that coefficient so I'm in scientific notation. Now I need to make this one smaller. So I need to make this one smaller by moving this 1 decimal place, which means that I need to make the power of 10 bigger by 1 decimal place. And I do that by adding a 1. So using that really nice pattern, I end up with 1.28, making that number smaller, times 10 to the negative 13 plus 1 is negative 12, and we've got our answer in scientific notation. Next up is division. I'm going to start off by writing this in fractional form. So I've got in my numerator that first number in scientific notation. In my denominator, 4 times 10 to the 7th. I'm going to group these, 1.2 divided by 4, multiplied by, and then I've got 10 to the 15th divided by 10 to the 7th. Now I need to do that 4 into 1.2. So let's do that division. 4 goes into 12 3 times. 12 with a 0 left over, and I just bring that decimal place up on top. So my coefficient out in front is 0.3. It needs to be bigger, right? But we'll keep going here for now. And then my power of 10 is 10 to the 15 minus 7. So this gives me 0.3. It's supposed to be a 0 times 10. 15 minus 7 is 8. Now I need to make that 0.3 bigger by moving one decimal place. If I made that bigger, it means I need to make my power smaller. I moved one decimal place, so I'm going to subtract a 1 here. Okay, so what do we get? We get 3 times 10 to the 8 minus 1 is 7. Next, I want to add these two together. And in order to add them together, they need to be the same kind of number. Or you can think of it as being on the same order. So this one is a 10 to the 15th number. This one is a 10 to the 14th number. So I cannot add these together the way they are. So instead, I need to make the powers on the 10 exactly the same. It really doesn't matter which one you start with. You're just going to need to make sure your final answer is in scientific notation. I'm going to start with this one, and I really want to make this power here 14 to match the power that I've got here. So that means I'm going to take that 3.2 times 10 to the 15th, and I need to subtract a 1, which means that I'm making the power smaller. So I need to make my coefficient bigger. So to make it bigger, I'm going to move it one decimal place, giving me a 32. So I've got 32 times 10 to the 15 minus 1 is 14. Now I can add that to my 4 times 10 to the 14th. This is really now just a matter of looking at my coefficients. I've got 32 of those 10 to the 14ths, and then 4 more of the 10 to the 14ths gives me 36 altogether. So I've got 36 times 10 to the 14th. One thing to fix, my number out in front, that coefficient is too big. So I'm going to make it smaller by moving my decimal. That gives me a 3.6. And then I need to make that 10 to the 14th, since I made the coefficient smaller by one place, I need to make my 10 to the 14th bigger by one place. So I'm going to add a 1 here, and that gives me, I'll use that same color blue there, times 10 to the 14 plus 1 is 10 to the 15th. Next up is a subtraction, and I'm going to work with this exactly the same way. I really want the powers on the 10 to be of the same order or the same number. So I want to make this 10 to the negative 6. I need to get to 10 to the negative 8 instead. Why don't I write that down? I really want this power to be a negative 8, so it matches that power. That means I'm going to need to subtract a 2. I'm going to make it smaller. So as I'm working with this, I've got 5.8, leave yourself a little bit of room here, times 10 to the negative 6. I need to subtract a 2. If I make this smaller by subtracting a 2, I need to make the coefficient out front bigger by 2 decimal places. So I'm going to go 1, 2 decimal places. So I get 580 times 10 to the negative 8th, perfect, minus 3.1 times 10 to the negative 8th. Now I've got the same type of number, and I can go ahead and just combine those coefficients. How many 10 to the negative 8s do I have? So I really need to do 580 minus 3.1. You can use your calculator. I'm going to use my brain. 580 minus 3 is 577, minus another 0.1 is 576.9. Okay, so we've got 576.9 times 10 to the negative 8th. Almost, right? But I need to make the number out in front smaller. It is too big. We're going to make it smaller by 2 decimal places, which means that I need to make the power on the 10 bigger by 2 decimal places. So we end up with a smaller number out front, 5.769 times 10 to the, we end up with a bigger coefficient by 2 on the 10. Negative 8 plus 2 is negative 6. You are doing great with these operations in scientific notation. Watch this video next.